intermolecular forces and the properties. Many properties of particles, many physical properties, depend upon the number and type of intermolecular forces. So, many physical properties depend upon the number and type of intermolecular forces, IMF. Remember these two tenets: breaking bonds needs energy. You need to put energy into it. It requires energy. And forming bonds releases energy, gives off energy. Okay, one of the physical property we're going to talk about is change of state. We talked about this previously. What happens in melting is energy is needed to break some of the bonds between solid particles. Freezing, then, if energy is needed to melt, freezing would be releasing energy. And evaporation / boiling is the energy needed to break all of the bonds, intermolecular forces. So if you break all the bonds, then they are separate from each other, and that's called a gas. Water. Some properties of water. Generally, small molecules are gases, but water is a liquid due to the very strong hydrogen bonds. If there was not hydrogen bonds at room temperature, water would be a gas and not a liquid. Viscosity. Viscosity is the resistance to flow. Think oil, pancake syrups, things like that, molasses. Why do some things, some liquids resist flow? Why they move very slowly? It's because they have long molecules, so they get intertwined with relatively high intermolecular forces. The long molecules, the molecules get intertwined each other. Think about trying to pour spaghetti out. It doesn't come out as a nice little stream. It comes out as one big glop because the spaghetti noodles are intertwined with each other. So if one goes, they all go. But remember, there's a lot more below it to keep it back. And the intermolecular forces, that means they keep them together. Solubility. In order for something to be soluble, the liquid solid intermolecular bond, intermolecular force, must be stronger than the forces between the liquid and the forces between the solid. If the liquid likes itself more than the liquid-solid bond, it's not going to dissolve. If the solid likes itself more than the liquid-solid bond, nothing's going to happen. You got to have a stronger bond, stronger force between the liquid-solid particles than with the solid. The solid and the liquid and liquid. Now we come to the part about the chapter oil, water, and soap. Oil and water don't mix. This is because water is more attractive to itself. Water has a very strong hydrogen bond with itself. So it's rather going to, it's more attracted to itself, and it's not going to try to attract the oil. So it's not going to do it. Because the water has the hydrogen bond and more attracted to itself than with the oil. It's not that the water could overcome the oil, IMF and the oil with each other. It's just that it's more attracted to itself. What you need then is soap. Soap is a long molecule, and it has a polar end and a non-polar end. The polar end attracts water. The non-polar end attracts grease. And what it does is it forms a little soap bubble called a micelle. So you have some oil or grease here, and you add soap. If you have water, water's ignoring it, it's going about its own way. But if you add soap, then what happens is it surrounds it like this. The nonpolar end, without the circle on it, is attracted to the nonpolar oil, and the polar end, circles, is attracted to the water. It forms a little protective circle about it, which the water can then take away and flush down the drain. So this is how soap works. The last thing is surface tension. and soap, which is another factor that soap helps out with. Surface tension is what keeps molecules from spreading or being penetrated by an object. So it keeps molecules from spreading. Or being penetrated. The spreading part is like water beating up over a glass. If you look at a glass filled with water, here's your glass. If you fill it up slowly and gently, you can see that the water overcomes. So the water can go over the lip of it. And what's happening is the water molecules are pulling itself back. Penetrated is like water bugs and small bugs that stand on the water because they're so light, and they use the surface tension to keep from falling into the water because their legs don't go sharply at it. What they do is they spread out, and it keeps it from penetrating the water. And this is the reason for beating. This is why you need wax on your car. It prevents water from penetrating the surface to rush out your car. And it's why you need soap to get your car clean. What soap does is it reduces the surface tension by reducing the attraction of the water molecules with itself. And that way it breaks it down and it prevents bubbles, beads of water from forming. And that will help penetrate the dirt and grime on your car. That concludes this lesson on soap.